Okay, so for this question, we want to find dy by dx when x is equal to t over 1 minus t and y is equal to 1 over 1 minus t squared. So again, we should be thinking, right, dy by dx, these are both given in terms of a third variable t, so we're going to need to differentiate both of these, so we can use the chain rule such that dy by dx is equal to dy by dt times dt by dx. Now, I've got a little bit more work to do for each of the expressions this time. So let's break off the x expression to start with. X is equal to t over 1 minus t. Now, we want to differentiate it. We should be looking at that thinking, well, this is a fraction, which it is. And if it's a fraction, well, there's a rule we can use to differentiate. Which rule is it? It's the quotient rule. So we should be remembering that for our quotient rule, in terms of u and v, vu dashed minus uv dashed over v squared. Okay, should be familiar with that, should have used it lots of times at this point. So we need to get our 4 parts for this then. So we have our u, which is our numerator t. We have our u dash, the differential with respect to t of t is 1. Our v is our denominator, so 1 minus t, and our v dash, which is the differential of this, which the 1 goes to 0, the minus t goes to minus 1. So therefore, dx by dt then is our v, 1 minus t, times our u dash, which is 1, minus our u, which is t, times our v dash, which is minus 1, all over our v, which is 1 minus t, all squared. So tidying this up a little bit then, we have 1 minus t times minus 1 is plus t, over 1 minus t all squared, or in other words, dx by dt is equal to the minus t and the plus t cancel, 1 over 1 minus t all squared. So that's our expression for dx by dt. We now need to do something similar for dy by dt. So if we look at our expression, y equals 1 over 1 minus t squared. And for this one, let's go with a slightly different rule for this one, so we've practiced it. Let's rewrite this as 1 minus t squared to the minus 1. And if we write it in that form, well, what can we then use? We can use the chain rule. So therefore, dy by dt is equal to, bring the power to the front of the multiplier, minus or minus 1, leave the function as it is, so 1 minus t squared in the bracket. We reduce the power by 1, so minus 1 becomes minus 2. And then we multiply it by the differential of this bracket of this function, which is minus 2t. So if we simplify that a little bit, the minus and the minus will cancel. In our numerator, we have 2t over our denominator, 1 minus t squared, all squared. So now we can bring those together and say, therefore, dy by dx, using our chain rule, dy by dt times dt by dx is equal to our dy by dt, which is 2t over 1 minus t squared all squared, times our dt by dx, which is when we flip this fraction, so the flipping of dx by dt. So actually we are just multiplying it by, in the numerator, or if we want to write it as the full fraction, 1 minus t squared all over 1. So tying that up a little bit further, we have 2t times 1 minus t all squared, all over 1 minus t squared all squared. And you might be thinking that's our final answer, but actually there's a little bit more that we can do, because really in the denominator here, this 1 minus t squared, well, there's a little bit of an algebraic trick hidden in there. Really, we have ourselves a difference of 2 squares. So we can split this into 1 minus t times 1 plus t all squared. Which, thinking of our powers, well, really, if this is all squared, it means we've got 1 minus t times 1 plus t all times 1 minus t, 1 plus t. So you've got 2t, 1 minus t squared over, or 1 minus t squared times 1 plus t squared. And what's going to happen, these 1 minus t squareds are going to cancel, leaving you with 2t over 1 plus t all squared. And that is our final answer for dy by dx, when x is equal to t over 1 minus t and y is equal to 1 over 1 minus t squared.